Hi, I'm Pamela Fennell. I'm an Associate Professor in Urban Energy Modelling working in the Building Stock Lab. And I'm going to talk about air conditioning too, okay? I'm going to take a slightly different perspective to Jason. I might even take issue with a couple of things that Jason has said. But the perspective I'm coming at it from is about how can we use large-scale, high-resolution computer simulation models to explore what's going to happen with climate change and to explore what we can do about that. And we're looking at what impact all of that air conditioning that Jason was talking about might have on the electricity network. He did steal my thunder. I was going to start by saying this is typical British summer weather, as we used to think. But of course, the reality is it is getting hotter. Okay, so this is summer 2022. That was the first time that we reached 40 degrees in the UK. This is Greenwich Park, usually beautifully green and looking incredibly parched. It's a really striking photo of what really happens and what we are seeing more and more of. And Jason went through the statistics in terms of what we're expecting. But the Met Office is predicting that by the end of this century, those sorts of temperatures won't be freak occurrences, but they'll be something that comes back every 3 years in the UK. So this is the new world that we are living in. And that heat has a huge impact on well-being. In 2022, we saw over 3,000 excess deaths due to the hot weather. Even last year, not nearly so hot, but with some hot spells, the Health Security Agency estimated that there were over 1,500 excess deaths due to the hot weather. And as Jason said, the most vulnerable are the elderly. They're people with underlying health conditions and they're infants because they don't sweat so well, so they can't cope with the heat. But that heat affects everybody, okay? It makes a huge difference to your ability to go about your everyday life. And one of the most reported things is it has a really big impact on your ability to sleep at night. And that impacts productivity, that impacts your mental health if it goes on for very long. And while I love Jason's images of shading, the reality is that an awful lot of the building stock in the UK is simply not able to cope with that kind of hot weather and was built in a time when it just wasn't a consideration. Okay, so dense urban areas with lots of hard surfaces, a little bit like Argyris was saying earlier in some of the settlements that he had been looking at, where there's a lack of trees, there's a lack of water that's going to cool things down. There are real problems for people who live there. The problems are worse if you live in flats. You have far, far fewer options for making a difference. And if you rent, it's even worse. And if you live here and it's 40 degrees, you are going to go to the supermarket or to the DIY shop and spend £150 on a portable air conditioning unit, because that's what's going to mean that you can sleep at night. And that's what's going to mean that the rest of your family is going to be safe. So we have seen increasing numbers of purchases of air conditioning units. And what happens is generally that you'll see a hot spell triggers a lot of purchases, and then once you've got it, you keep using it. It doesn't need to be 40 degrees to turn it on, but if it's 26, you might start turning it on. So once you have it, you do start using it. So around 65% of offices already have air conditioning in the UK. It's about 30% of shops and retail premises. The number for the domestic sector is probably about 5% at the moment, but it's going up all the time. And the introduction of reversible air-to-air heat pumps means that lots more people are going to have access to cooling. So it's something that is coming. Now, I'm not saying that we are suddenly turning into the Mediterranean, okay? I'm sure Cliff will be delighted to know that I still think that heating is important, okay? And he'll follow up with that later. But because the fact is, it doesn't matter how much energy you are using over the course of a year. in terms of the electricity network. What matters is how much you use at any one time. So more and more of us having air conditioning units which we turn on for short periods of time. It might only be a few days in the summer that we use it. What matters is what is that peak load and how is our electricity network going to deliver that. So we have an electricity network that has broadly been based on generation at power stations, and that high voltage electricity is then transformed into the lower voltages that we use in our homes at substations. We've got just over 500,000 secondary substations in the UK. They serve each one, probably 100 to 500 households will be served by one of those. If we have to start investing in all of those and upgrading all of those to deal with summertime peaks in electricity demand, that's an enormous cost. And so the CoolDown project, which was funded by Ofgem, worked with electricity distribution network operators. So we've been working with SP Electricity Northwest and National Grid Electricity Distribution to try and explore the impact of this. And we started by taking their monitoring data for those substations and trying to look at what the load patterns are, what are typical substations. And once we'd worked out what typical substations were, we started to think about building models that went building by building so that we could assess the loads that were being placed on those substations today and how that might change as the UK warms. And what we found is that actually large numbers of buildings are already overheating. So you might have expected that in London. These are results for 2 separate substations. These are actually in the northwest, so where you would have thought there would be a lot less overheating. But nonetheless, what we're seeing for these 2 substations is in 2030, we're seeing between 30 and 50% of buildings are already overheating. And then that gets worse decade by decade as we go through. And what we've assumed in our modelling is that not everybody is going to respond to that. So we're not trying to project some sort of worst case doom and gloom scenario. We're actually trying to say just, what realistically might happen. So by 2050, we're assuming that about 60% of households who are overheating are likely to install air conditioning, and about 80% of non-domestic buildings which are overheating are likely to install air conditioning. And the impact on the electricity distribution network, even with those relatively conservative assumptions, is huge. So we see very small numbers of substations currently that have their peak load in summer. And then we see virtually all substations by 2050 having cooling demand in the summer, and large numbers are having their peak load in summer now instead of in winter. And that's what's triggering massive investment to make sure that the lights stay on when everybody switches on their air conditioning. And the potential impact in cost terms is tens of millions of pounds, even though some of these substations will eventually need to be upgraded in order to allow for heat pumps to be installed. But this is likely to happen first and bring that investment forward. There are things we can do about it. One of the big things is potentially behaviour change. So cooling demand response is basically rewarding people, businesses or households, for adjusting their thermostats when the demand on the network is highest. And when we've looked at the modelling for that, we've found that we can potentially reduce the loads, the peak loads, at most substations by about 9%, which can have a big impact on how much money we're going to need to spend on that reinforcement. The problem with demand response is you have to get the design right. If you're not careful, you'll find that as soon as the demand response period ends and it starts being cheap to run your air conditioning again, everybody turns theirs back on at exactly the same moment, and the peaks are actually higher than the one you thought you had avoided. So just to finish up then, as the UK continues to warm, more air conditioning is inevitable. That's going to have a big impact on the network, and dealing with that is going to cost a lot of money. That money is going to come from individual consumers' electricity bills, whether that's households or whether that's businesses. And demand response is one of the ways that we can start to try and bring that down. But we will need some of Jason's suggestions as well. Thank you.